So now we are going to implement the second idea. What was the second idea? In the first idea, we looked at increasing the payoff associated with this new action or this new behavior can cause a complete cascade. In our second idea, we were to talk about key people, right? We are going to keep the payoff associated with a particular action same, but what we are interested in looking at is, we'll take this network again and we'll see that when we start with some particular bunch of nodes, it creates a complete cascade. But if we start from some other bunch of nodes, they are not able to create a complete cascade. It means that different nodes in this network have different power to create your cascade, and these bunch of people which if chosen creates your complete cascade, they are known as the key people. Again, I would like to remind you about digital marketing and choosing the right set of people to popularize your idea. So what we are going to do in the second screencast is, we are going to take a network and then we are going to choose different sets of initial adopters, and we look at while certain sets are able to create a complete cascade, other sets are unable to create a complete cascade. So I'll just take this same code and I put it in a different file, idea2.py. Okay, so now what we do is, first of all, I change my payoff. Let's say the payoff associated with A is 9 and with B is 5. What we want to do is, I'm going to take two initial adopters. So these two initial adopters can be any two nodes in the network. So for every possible set of two nodes in the network, we'll start the cascade from there and we'll check whether these nodes have been able to create a complete cascade or not. And we are using the same previous graph as before, random_graph.gml. So what I'm going to do here is, for u in g.nodes and then for v in g.nodes, I do not want my sets to be repeated. So if I do it for like this, for u in g.nodes, v in g.nodes, 1, 2 means node 1 and node 2 will come once, and node 2 and node 1 will come once. Rather, node 1 and here again it will choose 1 again. I do not want such kind of repetition. So I put a loop here, not loop, condition here. If u is less than v, only then it is what I am doing will be considered. So if u is less than v, now I create my list 1. So for every possible values of u and v, what I do is, I append both of these values in my list.append u and then list1.append v. So what is happening here? Now list1 consists of my initial set of adopters. So this particular loop condition will go through and take each and every set of two nodes in my network, and after taking each and every set of two nodes in the network, we can see whether my cascade was complete or not. So I'll just shift everything inside these loops. Okay. I do not want to draw my graphs here because there will be so many sets and we can't see the graph for each and every set. It will be a time consuming process. We just want to see whether the cascade is complete or not. And here also we do not want to draw this graph. Okay, and also what I do is I print the values of u and v here so that I know what is happening, for which nodes we are getting the particular result. Okay, so what this piece of code is doing, let me quickly show you. So we have a network here, random underscore graph.gml. For every possible set of 2 nodes, we take them as the initial adopters in list 1. We start the cascade from these 2 nodes and we see at end whether these 2 nodes result in a complete cascade or not. So it's a simple code. Let's run it here now. Okay, so let's see. This is the result. So for all possible set of nodes, you see here, for most of these sets, the cascade remains incomplete. But there are few sets here, like 0, 2, and then 0, 9, and then one here, 2, 9. So only these 3 sets, they result in a complete cascade. All the other set, they results in an incomplete cascade. This shows us that yes, there are certain key people, certain keynotes in this network, and if you start your cascade from there, it tend to become a complete cascade. Proving our second idea that yes, there are key people in this network.